So in the last video, we went over the definition of the derivative, the limit definition of the derivative. That limit definition has a lot of purposes, but when you're going to be first learning Calculus 1, you're probably going to spend a short amount of time on that limit definition because that's used a lot in higher level calculus. But in Calculus 1, you're going to be introduced to some calculus differentiation rules that help simplify that whole process. So in this video, I'm going to be going over the derivative rules and basically showing you guys a way to find derivative much faster and much easier. So starting off with the derivatives, first I'm going to go over the basic rules for derivatives, differentiation rules, and these are rules that you're probably going to have to memorize, so I just want you guys to know about that. So the first rule is the constant rule, and the constant rule basically means that any constant, whenever you take a derivative of a constant, its derivative is equal to 0. So I'm going to denote a constant c, and when you take the derivative of a constant c, its derivative is 0. And the same thing can be said for x, the constant x right here. Whenever you take the derivative of x, which is just a single variable, its derivative is equal to 1. So let me actually box this. So major key is that the derivative of a single number, such as, let me give you an example, such as let's say you want to take the derivative of the number 2. Its derivative is just 0 because it's just a regular number, a regular integer number. But when you take the derivative of, say, just x, it's equal to 1 because it's just one variable. This is x is just x to the first power, and its derivative is just 1. Now the second rule is going to be the power rule. The power rule for derivatives. Now I'm gonna when I'm writing these rules, I'm gonna write them in a very generalized way, but then I'll follow with a small example. So the general formula for the power rule is that whenever you have x to some power greater than and x to any power, when you have x to any power, so for x to any power, I'm just going to denote it as alpha, x to alpha. Whenever you take the derivative of x to alpha, where alpha is any real number, the alpha actually becomes a coefficient of the x, and the power of alpha is subtracted by 1. So I'll give you an example. Say we have the function in x is equal to f of x is equal to x to the 4th. So in this case, alpha is equal to 4. Alpha is equal to 4. So you see in this formula, the alpha is brought down as a coefficient of x, and then the original alpha in the power is subtracted by 1. So we're going to do the same thing here. So x to the 4th, we're going to bring down 4 over here, So we get 4 to the x to the 4th. But then you see that we subtract 1 from the original power. So we get 1 minus 1. And our final derivative is 4x. 4 minus 1 is 3. And our final derivative, so our derivative of x to the 4th is 4x to cube, 4x cubed. Now, the next rule is the next rule is going to be the product rule. And the product rule is it's a rule, but I would consider it more of a property of derivatives. But it's still you could still say it's a rule. So in the product rule, this helps you basically find the derivatives of products, basically two different functions, either two different functions being multiplied together, or two different variables being multiplied together. So I'm gonna denote those two different let's say functions as u and v. So say u is equal to f of x, v is equal to g of x. These are two different functions, and the product rule is applied when we're multiplying these two different functions. So I'm gonna say y is equal to u times v. Right? We have a product here, so we want to find the derivative of this product, and we find that. So y prime is equal to u prime v plus u v prime. So this right here is the product rule, and it's basically saying that to find the derivative of u times v, which is basically f of x times g of x, we have to apply this rule right here, where we take the derivative of f of x. So we take the derivative of, so first we take the derivative of f of x. As we know, it is u, so it's u prime right here. So we take the derivative of f of x and we multiply it by the function g of x, and then we add that will be whatever we get to another product right here, which is f of x times the derivative of g of x. And then a quick example of applying this rule is when, say, if you multiplied, say the function is y is equal to x squared. So this is going to be f of x and times, let's see, so let's do x to the third. Let's do x to the third. So x squared times x to the third. Actually, you know what? No. So x squared times, let's do x cubed plus 2. Let's do that. So we want to find the derivative of this. But how do we find the derivative of this? We apply the product rule. So we know that f of x, or in other words u is equal to x squared, and then g of x, or in other words v, is equal to x cubed plus 2. Now, we use the formula, so we know u prime is just the derivative of f of x, and we already learned how to take the derivative of powers. So the derivative of x squared is just 2x, because we brought down the 2, subtracted 1 from the power, and then so we brought down the 2, subtracted 1 from the power. 2 minus 1 is just 1, and then x to the first power is just x. So the first thing we're gonna plug in is 2x, right? Because the derivative of f of x is equal to 2x. Now, the next step is, it says that multiply the derivative of f of x with v, which is g of x. But we don't take the derivative of it, we just leave it as the way it is. So right here, we just plug in x cubed plus 2, because that's what g of x is. Now, the next step, it says that multiply f of x times the derivative of g of x. And so we're not taking the derivative of f of x this time, we're taking the derivative of g of x this time. So f of x is just x squared, and the derivative of x cubed plus 2. And this function right here, I already taught you the constant rule and the power rule. This is a combination. This is a combination of both powers, both rules. So there's gonna be two derivatives here. One for the variable, one for the constant. So the derivative of x cubed is just like how we did it before. We bring down the 3, subtract 1, and the derivative is 3x squared. And over here, this is a constant. 2 is a constant. When you take the derivative of 2, its derivative is 0. So our final derivative is basically 3x squared plus 0, which is just 3x squared. So that's the derivative of g of x. That's the derivative of g of x. So we're gonna plug in our derivative right here, back into the formula. So 3x squared here. Now, after this, we figured out all the derivatives and we use the formula. Now we just have to simplify. So this is just gonna be regular algebra and like the distributive property. So you just distribute 2x. So 2x times x to the third is just 2x to the fourth. 2x times 2 is just 4x. And over here on this side, it's just x squared times 3x squared. And that is going to be 3x to the fourth. Now you can simplify even more. You can just, we can add like terms. 2x to the fourth plus 3x to the fourth. 5x to the fourth plus 4x. Our final derivative is this. So this is actually the simplified form of the derivative. But if you wanted to, you could have left the derivative just like this, just like how it was. But it's much better to simplify the answer, because it's, the simplest form is I would consider the best form. So you could have left it like this, and your professor might leave it like this. But I would recommend simplifying, because this is pretty long and it could look confusing. And once you simplify it, it makes a lot more sense. Now moving on, the next rule is so we just went over the product rule. There's also a quotient rule when we're dividing two functions, when we want to take a derivative of quotients. So quotient rule. So similarly, I'm going to label u as f of x and v as g of x. So So I'm going to label u as f of x, v as g of x. But the formula will be a little different. So in this case, now we're not going to be multiplying the functions. We're going to be dividing the functions this time. So y is equal to u, which is f of x, divided by v, which is g of x. Now when we take the derivative, we want to take the derivative of this. It's a longer formula for the quotient, just because any fraction, whenever anything comes into a fraction or a root, it becomes a lot more complicated. So the same thing happens when we try to take a derivative of a function of quotient. So the general formula of the derivative of u over v is going to be u prime times v minus u v prime over v squared. So you see how it's a little similar to the product rule, but it's a whole lot different, because over here you're actually adding two products, and in the quotient rule you're actually subtracting two products and then dividing by a square. So this right here is the general formula that you're probably gonna have to memorize. So I'm gonna give you guys a quick example of this formula, this formula in action. So a simple example right here is, let's say f of x, aka y, is equal to 4x squared plus 3 over 2x minus 1. So in this case, the top function is f of x, bottom function is g of x. That's how it's always going to be. U is always going to be on the top, v is always going to be on the bottom. So first things first, same thing, same way how we took this, we found the product, the derivative of the product rule. We do the same thing with the quotient rule. So first things first. First we need to find the derivative of u, and we know u is f of x, so we need to find the derivative of f of x. So let me actually switch this f of x into y so it's not confusing. So it's y is equal to 4x squared plus 3 over 2x minus 1. So in order to find y prime, first we find the derivative of f of x. So we know that f of x is equal to 4x squared plus 3. When we take the derivative of that, this once again this derivative forces you to apply the constant rule and the power rule that we already learned in the beginning of this video. So the derivative of 4x squared, we just bring the 2 out into the front, then we subtract 1. So what happens here is that the coefficients, there's going to be two coefficients, 2, the 2 and the 4 that was already there, then x, then 2 minus 1 is just 1. So we have 2 and 4 right next to each other, and they're both going to be, those coefficients are just going to be multiplied with each other, and we get 8x. So the derivative of 4x squared is just 8x, and the derivative of 3, as we know, is just going to be 0 because it's a constant. So the overall derivative of 4x squared plus 3 is just 8x, right? Now we can plug this back into the formula. So now we know that what u prime is, so it's going to be 8x, and it says, the formula says that we had to multiply it by v, which is g of x, but we don't take the derivative of g of x for this product right here. So g of x we know is 2x minus 1, so it's 8x minus 8x times 2x minus 1 subtracted by, now the second part of the formula is that we had to multiply u by the derivative of v prime, the derivative of v, and v is g of x. So So now we have to find the derivative of g of x. So g of x is 2x minus 1. So same procedure. The derivative of 2x is just equal to 2, because it's just equal to 2 because we know that the derivative of just x is equal to 1. So when we take the derivative of 2x, it's just going to be 2 times 1, which is just 2. And then right here, the derivative of -1 is just 0 because it's a constant. So the overall derivative of 2x minus 1 is just 2. We plug that back in to the formula. So we know that u is equal to f of x. F of x is equal to 4x squared plus 3. And do not forget about these parentheses. You can make a very big mistake if you forget those parentheses. So 4x squared plus 3. And we multiply that by the derivative of g of x, aka v, and that is 2. So we figured out the numerator. Now the denominator says that we need to divide this entire numerator by v squared, meaning g of x squared, and that's simply 2x minus 1 squared. That's it. And we could leave the derivative just like this, but once again, I would say simplify. I consider simplest form the best form, I guess. So first things first, in order to simplify, we multiply this out, multiply these products out. So 8x times 2x, this is just going to be 16x squared. 8x times -1 is just minus 8x. And we keep this in parentheses so we don't make any mistakes. Subtracted by, so this is going to be 2 times 3, which is going to be 6 plus, and then 2 times 4x squared, which is just 8x squared. And remember, you see that I kept the parentheses because now in the numerator we're gonna have to distribute this negative, because whenever you see something like this, there is a imaginary 1 right here that you're gonna have to distribute in order to get rid of the parentheses. So that's what we're gonna do right now. Derivative distribute that -1. And we can keep the denominator the same. I don't want to expand that entire binomial. It's gonna get pretty big then. It's gonna give her. It's already in simplest form. The denominator is already in simplest form. We don't want to touch that. So we get 16x squared minus 8x, and we distribute that negative sign. -1 times 6 is just positive 6. -1 times 6 is just -6. And then -1 times positive 8x squared is going to be -8x squared over what we already had. Now we add like terms in the numerator, and we get 8x squared minus 8x minus 6 over 2x minus 1 squared. And our final simplified derivative is this. So these were some of the major properties, I would say, but for specific rules, there's a whole list of specific rules. If you need like a table or something, you can actually just search it up on Google. you can search up a table of basic derivatives, and it will pop up. And most calculus teachers will let you have one during exams or quizzes. So, but it's very beneficial if you take the time to actually memorize those derivatives. So you're not always going back to that table during exams or quizzes. So I'm just gonna list. I'm just gonna give you guys a quick list of some of the basic derivatives. And once again, what I went over before, those were basic properties of the derivative that you're gonna see a lot, and they're basically ingrained into problems, and you just need to know when to use them. So, some basic derivatives. I'm gonna start with the So I already went over some of them, which is the constant rule and the power rule. These are very common, that's why I put them first, and I consider them properties as well. So I'm gonna go into some of the logarithmic derivatives. So the derivative of e to the x is just e to the x. The derivative of a to the x, and a is any real number, and it's basically an exponential function. I would say actually any real number greater than 1, greater than or equal to 1. And the derivative of this is just a to the x times ln of a. Derivative of ln of x is equal to 1 over x. Derivative of log a x is equal to 1 over x ln a. Now I'm going to go into some trig derivatives. Derivative of sine is equal to cosine x. Derivative of cosine x is equal to negative sine. Derivative of tangent is equal to secant squared x. Derivative of cotangent x is equal to negative cosecant squared x. And there are also inverse derivatives. So the inverse of the derivative of the inverse of sine is equal to 1 over 1 minus x squared. The derivative of cosine x, derivative of inverse cosine x is equal to negative 1 over 1 minus x squared. Derivative of tangent inverse is 1 over 1 plus x squared. And these will basically be the most common for the inverse cotangent, inverse secant, inverse cosecant functions. You're not going to see them a lot, but so you should still know them, but you're not going to see them a lot, so I'm not going to list them here. But inverse of cotangent, you might see a little bit in some integral problems, stuff like that. So I'll still list it here. So the derivative of that is just negative 1 plus x squared. So these are some of just the basic derivatives and some of the basic properties of derivatives. And I would recommend memorizing most of these, so you have a basic foundation in derivatives.